Multiplying and dividing rational expressions. In this section, what we're going to talk about is multiplying rational expressions. So if P over Q and R over S are rational expressions, then P over Q times R over S, what you're going to do is multiply the tops and multiply the bottoms. So you're going to get PR over QS. We learned how to multiply fractions in elementary school, and it's the same concept. You multiply the tops and you multiply the bottoms. So to multiply rational expressions, you're going to multiply the numerators and multiply the denominators. Alright, so rules for multiplying rational expressions. Number 1, completely factor the numerator and denominator. Number 2, multiply numerator and multiply the denominator. Number 3, simplify or write the product in lowest terms by dividing out any common factors. So, it's what we did in elementary school. You're going to multiply the top, multiply the bottom, and then you're going to reduce anywhere that you can. Alright, so let's try one. So here, what I would like to do is I would like to reduce at the beginning if I can, since all of these are monomials. These will not factor because remember with your rules, completely factor the numerators and the denominators. Well, when you have monomials, you cannot factor. So since I can't factor, I can reduce from the very beginning. So I'm going to have 6 will go into itself one time, and 6 will go into 12 two times. 5 will go into itself one time, and 5 will go into 10 two times. Alright, so now what I also have is I have an x here that will cancel out, and I have 3 x's down here, and one of those will cancel out with this one, leaving me with an x squared. So now I can multiply straight across, and it's a little messy, so you have to keep up with your inventory. So for the top, I have x squared times 1, which is just going to be x squared. And for the bottom, I have 2x squared times 2, which is going to be 4x squared. Well, notice that we can reduce again because these factors of x squares will cancel out. But remember, when things cancel out, it goes to 1, so I get 1 over 4. Now, let me show you something else that you could do. You have 6x squared over 10x cubed times 5x over 12. So you can multiply the tops and get 30x to the third over, multiply the bottoms, and so we get 120x to the third, and you can reduce here. So I know 30 will go into itself one time, 30 will go into 124 times, and the x cubes cancel each other out, and I get 1/4. So it doesn't matter if you reduce within the problem like I did here, or if you multiply the tops, multiply the bottoms, and then reduce. But this only works if you have all monomials. If you have all monomials, you can do this. Look here, I don't have all monomials. I have one right here, and I even have a factor here that's prime. But I do not have all monomials. So what I need to do is I need to factor the tops and factor the bottoms if possible. So I'm going to just rewrite that m minus n times m minus n like that. And on the bottom, it's just going to stay m plus n. Times, I can't do anything with that m, and then here, there's an m in common, so I'm going to bring it out, and when I do that, I'm going to have m minus n. So now let's see what I will reduce. Only one of the m minus n's will cancel this one m minus n, and then this m will cancel this m, and so I'm left with m minus n over m plus n. Alright, so what about dividing? Well, to divide fractions, if you remember from, again, elementary school, what you're going to do, right off the bat, you can't divide fractions. Instead, what you're going to do is you're going to keep the first fraction as is, You're going to change division to multiplication, and you're going to flip that second fraction, and then you're going to follow your rules for multiplication. So to divide two rational expressions, you're going to multiply the first rational expression by the reciprocal of the second rational expression. So notice it says you're going to multiply. The first one stays as is, and then the reciprocal of the second one. And I like to call this keep, change, flip. Keep the first one as is, change division to multiplication, and flip that second fraction. So let's try this. Notice you have all monomials, so remember that from multiplication. So what we're going to do is we're going to take the first one and leave it alone. So we have 3x to the third y over 40. And then we're going to change division to multiplication, and we're going to flip that second fraction. So we have y squared over 4x to the third. So now what we can do is we can reduce now, or we can multiply straight across and then reduce. Let's do that. So on the top I have 3x to the third y times y squared. Remember, you can multiply anything you want. They do not have to be like terms. So I'm going to have 3x to the third y to the third. So the only thing I have to multiply are those y's. And on the bottom I have 40 times 4, which is going to be 160. And then I have my x to the third. And then from here I'm going to reduce, and I don't think 160 is divisible by 3. No. So I can't reduce the 3 and the 60. I can reduce the x thirds. There's nothing to reduce the y to the third. So I'm going to have 3y3 over 160. And that's going to be your answer. Let's try again. So I have x plus 2, and I'm going to go ahead and expand that, over 10 times 5 over 2x plus 4. Alright, so there's only one thing that I can factor, and that's this one here. So I'm going to leave everything alone, and I'm going to factor a 2 out of this one. Alright, so now I'm ready to reduce. Remember, you can reduce diagonally and up and down. Don't forget that. So diagonally, I'm going to take one of the x plus 2's and cancel it with that one. And then I'm going to reduce the 5. 5 will go into itself one time, and 5 will go into 10 two times. Now, these 2's will not reduce because you cannot reduce side to side. The only way that you can reduce is diagonally or up and down. You cannot reduce side to side. The only thing you're going to do side to side is multiply. And so I'm going to have x plus 2 over, the only thing I see on the bottom is 2 times 2, which is going to be 4. Now remember, you cannot reduce the 2 and the 4 because that x plus 2 is a group. So that 2 belongs to that x. You cannot reduce the 2 and the 4. Alright, let's try one more time. So again, I'm going to expand that x plus 3 just because it's easier to see. You don't have to if you understand that there's 2 there. And then I'm going to change division to multiplication, and I'm going to flip, and that 25 is going to go on top. And I'm going to go ahead and factor a 5 out of what is now the denominator. I factored a 5 out of this one right here. 5 will come out of both of those. And so now I can reduce, so I have x plus 3 and x plus 3. Now here I have a choice. I can reduce this 5 with the 25 up and down, or I can reduce this 5 with the 25 diagonally. We haven't done up and down, so let's do that. So this 5 is going to go to 1, and that'll go into 25 5 times. Now I can turn around and say this 5 will go into this 5 one time. So on the top, the only thing I have left is an x plus 3. And on the bottom, everything went to 1. And if there's a 1 on the bottom, I don't have to write it. But if there's a 1 on top, I do have to write it. So for example, if everything had canceled out on top to just 1, I would need to put that 1 there. But if everything cancels out on bottom, you can put the 1. It's not going to be wrong, but you don't have to put the 1.